Hi class, last lecture we finished the technical aspect of production, and today we're gonna start with the economic aspect of production, and we're gonna first approach economic aspect from the input perspective. So if there's an input perspective, then there's gonna be an output perspective as well. And the difference between those two perspectives is what is the choice variable. So what does that mean is that when the producer is deciding what to produce, how much to produce, is the producer deciding how much input to use, or is the producer first deciding how much to produce, which is what's first deciding the output, and then depending the level of output, the producer will then figure out how much input is needed. And later on, we will figure out that it doesn't matter which aspect, which perspective we start with, you will get the same results, which means that the level of input and level of output that the producer will end up choosing is the same. So why don't we start with the input perspective? The outline for today's lecture is gonna actually start with an overview of the technical aspects of production. And then after that very short overview, then we're gonna have a first introduce the economic concepts. And this is versus the technical or the physical aspect. Remember, for the last few lectures, we learned about TPP, APP, MPP, and the P in the middle means physical. But today, since we're studying the economic aspect, then we're gonna study some economic concepts. So for the input perspective, we're gonna study TVP, AVP, and MVP. The V in the middle means value, and value is different from physical. Physical, when you're talking about the outputs, you're talking about the, for example, the bushels, the kilograms, those. And for the value concepts, you're basically converting those physical quantities into dollar values. And so TVP, AVP, and MVP are gonna from the value of the output, or which are the revenue that the producer is gonna get. And then we also need some concepts from the cost side. And those are total factor cost, marginal factor cost, and we will also have average factor costs here. And after we are introduced, we finish introducing those concepts, then we're gonna study the profit maximization problem. And the first bullet point here is actually the condition for profit maximization. And I will spend quite some time explaining how do we find that condition, why did we ended up that that condition will lead to the maximum profit, and based on the profit maximization, what are the economic regions of the three stages of production. Before we start with the economic aspect of production, let's first have a very quick overview of the technical aspect of production functions. And here, for the last few lectures, we only covered the one output, one variable input case. And once we finish with the economic aspect of the one output, one variable input, then we will go back to the technical aspect of production again. But we will then go with multiple input, but still just one output. So the technical aspect of production, we first start with introduction of what are the what is a typical production process, and that typically have three components. The first one is input, and then input going through a production technology, then it's converted or transformed into output. And then we're saying that there's a lot of ways to represent or describe the production technology. And we can do it graphically or verbally, or we can use math. And for math, we introduced production function, and after that, we used production function a lot. And the production function that we covered is actually a short-run production function. And we also talked about the difference between short-run, immediate run, and long-run. It's basically depending on whether the inputs are fixed, variable, or a mix of those. So we started with a short-run production function where we assume there's only one variable input, and that way we can actually write the production function like this. Here the x1 is variable and x2 to xn are fixed, and for notation convenience we just write this short run production as fx1. Once we have production function introduced, we then started to introduce the several physical product concepts, which are TPP, APP, and MPP. So if you have a production function of y equal to fx, then y is basically your total physical product, which is TPP, and y over x is your average. And to help introduce the marginal concept, we spent some time introducing what is slope, what is derivative, and we mentioned that derivative is a generalization of slope. So slope is for linear function, and for nonlinear function, derivative is actually the slope of the tangent line of the nonlinear function. So once we have a good understanding of slope and derivative, then we introduced the MPP concept, marginal physical product. And marginal physical product is basically that if your function of interest is a production function where y is your output and x is your input, and you take derivative of y with respect to x, then that is your marginal physical product. It is a measure of rate of change. And we also mentioned that what you learned in your introductory economic course is AREC MPP, and in this course, we are using the point MPP concept, and it is the exact rate of change. So if you change your input or your x by a small, if there's a small change in your x, then what is the effect on y? And that's one way of describing the relationships between two variables in economics. And we later on, we also discussed the geometry of MPP with TPP and also MPP with APP. And later on, we introduced another concept of elasticity of production, or sometimes it's called factor of elasticity. And this it is the difference between elasticity and MPP is here. It is a percentage change in your outputs divided by percentage change in your input. So it's not changing y divided by changing x. Here, elasticity is a unit-free variable. That's a difference from MPP. So they both can describe how a small change in your inputs can affect your y, but it's measuring a little bit different changes. And with the factor of elasticity, we then introduced the 3 stages of production for a typical or neoclassical production function. Here, there are several special points, and those 2 lines actually separated the 3 stages. On this region, your elasticity is greater than 1, and in the middle region here, it's between 0 and 1, and on this region on the right, where your elasticity is smaller than 0, and your elasticity can also be written as your MPP over your APP. I missed one concept that we introduced after we cover MPP is the law of diminishing returns. So I also mentioned that law is saying that your marginal return to your input as you increase your input use will eventually decrease. There's actually going to be a assignment question about this, so I do hope that you can understand this law very well. So with that, that's basically what we have covered in the past few lectures. I went very slow because I want you to have a very good understanding of these basic concepts. Then for later on lectures, once you understand them very well, especially the marginal concepts, then your life will be much easier. I briefly mentioned the difference between the input perspective and the output perspective for the economic aspect of production. Basically, the difference is that when we're approaching from the input perspective, everything, including the revenue, costs, and profit, everything will be, in terms of algebraic function, will be a function of your input. Later on, when we are studying the output side or the output perspectives, then everything else will be written as a function of the output. And the output side, you guys are probably more familiar, which is the total cost, total revenue, marginal cost, those concepts. But I just decided that I'm gonna start with the input side, where you're not so familiar with, in case that that you have those output side concepts confuse you or something. But once you understand the input as a perspective, then the output perspective is much easier. Before we continue with the economic aspect of the production, we need to make some assumptions. And as always, you make a lot of assumptions in economics or maybe in also other field of research. But so here, the most important assumption is that the firm or the decision maker is a price taker. And that's when we say a price taker, that's about 2 markets. One is the output market. That means when the farmer has produced, for example, wheat, and then the farmer is selling that wheat on the market, and the farmer will not have any impact on the price of the wheat. So in that case, we see that the farmer is a price taker for the output. And the farmer is also a price taker for the input, for example, the fertilizer that they use. And when we also, so this assumption is also saying that when the farmer is buying inputs from the market, they also don't have any power influencing the input prices. For some producer, it might not be the case that the farmer or the producer is a price taker, but at least for most of agricultural productions and most of the inputs, that most of the time that the producer are price taker. So if the producer is price taker for both input market and the output market, then we say that the output prices, the output price and the input price are both given or exogenous, means that the farmer will have no influence on those prices. Then we will later on you will find out that the output price and input price, at least for this lecture, they will be constant. Another assumption for most of this course is that the objective of the producer is to maximize profit. There might be some exceptions to this assumption, but in general, the objective of producers are profit maximization. And let me mention a few exceptions. One exception is that I actually talked to some producers here that, for example, some cow producer, their objective is actually not to maximize profit in a particular year. Rather, they tend to accumulate their wealth, and then maybe they're hoping their children might continue with the production. So they are hoping to transfer the wealth to the next generation. And there are also cases where the objective is not to maximize profit, but rather to maximize output. So you may pause here a little bit and think a little bit to see if you can find examples of that. So it is very common here that you can read news saying that there's a yield contest, saying that the canola yield this year, there's a winner getting this much kilograms per acre or per hectare. So those the purpose of those producers is not profit maximization. Instead, it's output maximization or yield maximization. In general, it's a reasonable assumption to say that the objective of producers are profit maximization. Before I teach you how to find the maximum profit, let me actually ask you a question first. Is the firm maximizing profit at point C? So at this point, you should have already seen this graph multiple times. Point C is where TPP reaches its maximum value, and the MPP, which is the slope of TPP, is 0 at that point. So imagine this is the case for the canola yield contest. At point C, the winner of that yield contest reached its maximum output. But the question is that if the producer is actually going for profit, will that maximum output or maximum yield lead to maximum profit? If I ask you a question like this, the answer is probably no. And the answer is it depends, right? So it depends on the input price, the output price, and that is actually the objective of today's lecture is find out under what condition will the profit be maximized. First, let's figure out what is TPP, MVP, and AVP. And I hope when you read this abbreviation of these three concepts, it reminds you of TPP, MPP, and APP. And again, the P in the middle is physical. So that means it's a physical quantity of the output. And that is from the physical concepts. And then now the TVP and the MVP and AVP are very similar to those three physical concepts. But the difference here is that in the middle, V become value. So the difference between them is that for TPP, MPP, and APP, those are physical concepts, and you kind of need to assign some dollar values to your outputs. And if you do that, then we get the value concept, the 3 value concepts. So here TVP is defined as P is the output price times TPP. So TPP is your output in physical quantities, and P is the price of the output, which is usually dollars per unit. And we can further write this as P times Y if we assume TPP is a function, or we can also write it as P equal to Fx. And I'd like to mention here that in our assumption of perfect competition, or we assume that the firm or the producer is a price taker, then P is just a constant term. You can say, when I say constant, you can imagine, for example, it can be $5 per, I don't know, kilogram, or $2 per kilogram. But from your introductory courses, you probably have learned that P is a function of your output. If we draw the price and demand relationship, we usually have a downward sloping here. Let me put P here, and this is a quantity of your outputs. Then if you have a higher quantity demanded, then your price is gonna be lower. So usually there's a relationship like this. But if we assume that the firm or the producer is a price taker, then we just assume that price is a constant. So the price that the producer receives does not depend on the quantities that he or she sell. Again, if your price is a function of your quantity, which in our case is the output, then you can also write, because Y is a function of X, and you can ultimately write price as a function of your input. So this is a case where the firm is not a price taker. Again, if a firm is a price taker, then P is just a constant here. And in the graph, it's going to be a horizontal line. So the average value product, again, is very similar to APP. It's going to be TVP over X. And if you write TVP as a product of output price P and TPP, then you can actually write your average value product this way. And if you put APP back here, you can find out that average value product is just the price of output times APP. And this is similar to TVP, which is just price times TPP. MVP, which is a marginal value product, it's the exact rate of change of TVP, which is a value of your output. And those change in your value of output resulting from a small change in X, or an infinitely small change in X. Mathematically, MVP is again a derivative concept. It's a derivative of TVP, which is the value of the output, with respect to X. We need to pay attention here. On the bottom here is taking derivative with respect to the choice variable X. And this is because now we're approaching profit maximization from the input perspective, and X is the input perspective. And later on, when we are having the output perspective, then you will notice on the bottom it should be taking derivative with respect to the output. And if that's the case, then you're actually having the marginal revenue. So from the input side, we're calling it marginal value product. And from output side, we will call it marginal revenue. You're probably more familiar with marginal revenue than MVP here. Again, write TVP as a function, as a product of P, which is the output price, and the TPP, and we assume is a function of X. And we need to pay attention to this step here. So with the assumption that the farmer or the producer is a price taker, then P is going to be a constant. Or if you draw it in graph, it's a horizontal line. And if it's a constant, then when you're taking derivative, you can pull the P out. However, if we have time in this course, we might cover the case where it's not, P is not a constant, it's a function of X, then you cannot directly write it this way. So the condition that there's equality here is because we made the price taker or perfect competition assumption. And you can see here, if we can pull P out, then our life is much easier. It's because if you have P also as a function of X, then taking the derivative, you need to use the product rule. So we find that this term here, df over dx, is just MPP here, and again similar to AVP and TVP, which can be write as the product of output price and the physical concepts here. For MVP, it can also be written as P times MPP. So this P times MPP has a name, which is VMP. You need to pay attention here. V is in front of M. So here, MVP is marginal value product. So you're taking the marginal of the TVP, which is already a total value. However, here, VMP, it is the value of the marginal product. So pay attention to the order of value and marginal here. So if it's value of MPP, then it's P times MPP. Again, MVP and VMP equal to each other is because of the perfect competition assumption. Later on the course, if we have time, then we will introduce the difference between MVP and VMP. Let's do a quick example. Suppose this is your production function, and this is also your TPP, and your output price is P, which is a constant. Then what is the TVP, AVP, and MVP? So TVP is just your price times your TPP, and it is just equal to P times 6x squared minus x cubed, and AVP, it is TVP over x, and you can just plug what you wrote for TVP and divide that by x, and this is going to be 6x minus x squared. And if you have your TPP here, you wrote your APP, and your MPP. Then you can find out AVP is just P times your APP. And MVP is your derivative of your PVP with respect to X. And this is derivative of the whole thing with respect to X. And again, because P is a constant, we can pull it out. And you can find out that this is your MVP, which is just P times MPP, and that's your VMP. So we derived TVP, AVP, and MVP as functions of TPP, HPP, and MPP. And let's actually show on graph what are the differences or similarities between the value concepts and physical concepts. So this graph looks pretty much the same, like those physical concepts, graph of those physical concepts. The only difference here is that the TVP, AVP, and MVP, as you can see here, are scaled by P, which is the output price. So if I change the output price, you can see that, again, just as what I said, the curves are scaled by P. And if I change P smaller, then they're gonna shrink. But when I'm changing this price, you can find out for those special points, A, B, C, D, E, F, you can find out that their horizontal value didn't change. So for the inflection point, X is always equal to 2. It doesn't depend on the P. So when the output price change, is only the vertical values change. But those special points, for example, the maximum TVP is the same as the maximum TPP, the same input value. There are also corresponding cost concepts from the input side, and those are TFC, VFC, and MFC. Again, T total, V variable, M marginal. And this is, again, different from TC, VC, and MC. Those three concepts are from the output perspective, and you are probably more familiar with that. The variable factor cost, which is a VFC here, we defined as the input price here is R times X, which is the quantity of input used. And the total factor cost is just the variable cost plus the fixed cost. So B here represents the fixed cost. And for total factor cost, we use capital C, and for variable factor cost, we use small c. And you know that in the long run that all variables are variable, so there's no fixed costs. And C equals to Rx. If in the long run, that will also be the total factor cost. The marginal factor cost, which is MFC here, is, again, it's a value, it's a marginal concept, and it's the derivative of your either your total factor cost or your variable factor cost, taking derivative with respect to X. Here, the two derivatives are the same, is because B is a constant, which is a fixed cost here. And we know when we take in derivative of a constant with respect to a variable, then the derivative is going to be 0. So fixed cost is not affecting your marginal factor cost. And if we make the assumption again of perfect competition in the input market or the factor market, then R is a constant that's not depending on X, on the quantity of the inputs that the producer is purchasing from the market, then R will be a constant similar to the output price, where we also made the perfect competition assumption. Here are the graphs of the three cost concepts. We can say that TVC, which is a variable cost, is a small c, it starts from the origin because there's no fixed cost. This is only the variable cost component. So it starts from C and from the origin, and the slope of TVC is the same as the slope of TFC. They are both R, the input price. The difference is that TFC is actually shifted up from TVC. And I actually marked B there, so that the difference between TFC and TVC, the vertical difference is exactly B. So TFC is vertically shifted up by B. And marginal factor cost, again, if we make the assumption of price taker, we can find out that it's a constant equals to R, and in the graph it's a horizontal line. This is similar to the output price, which is also a horizontal line. Looks like we're not going to finish the profit maximization from input perspective in this lecture. And for profit maximization, we're going to first define what is the profit and how is that related to the value concepts and the cost concepts, or the factor cost concepts that we just introduced. And there are actually several conditions for profit maximization. And I do hope I can at least finish the first optimality condition for profit maximization.
Well, I guess we should start with what is profit. It might sound so obvious what is profit, but you might be familiar with profit as the difference between total revenue and total cost, and that is actually the definition from the output side. From the input side, the profit is defined as a difference of two terms that we have just introduced in this lecture. One is TVP and the other is TFC. Again, TVP here is the total value of the product, and TFC is the total factor cost. So F here means factor or input. And we introduced capital C to represent total factor cost. So this is the general profit. If we further assume perfect completion in both the product and factor markets, then profit can be written more specifically here. TVP can be written as a product of your output price and your TPP. And your total factor cost actually have two components. Here, this is variable cost, total variable cost, and B here is the fixed cost. So in the short run, there's a B here. However, in the long run, as we have explained, that all variables will be all inputs will be variable, and B will equal to 0 in the long run. Let's see what is profit in the graph. So there are several curves on this graph, and let me go over them one by one and explain what is the profit in this curve. The first one is TVP, which is the total value of product. You should be already very familiar with this curve. And the second one you need to pay attention here is the total variable cost. This is not the total factor cost. Remember, the difference between total factor cost and total variable cost is equal to a constant, which is a fixed cost. So your total factor cost, if I plot here, should just be the TVC line shifted up by the value of B. But because in the short run, the decision on input use is going to be based on variable factor cost, not on the total cost. It's because the fixed costs are already sunk. So whatever the producer is, whatever the decision of the producer is, that does not depend on the value of B. And then you can see here, this profit here is actually not the true profit. This profit here is TVP minus TVC. Your true profit should be TVP minus TFC. So if you want to know your true profit, you should actually, this one will be your TFC minus B. So your profit should, your real profit should also be shifted up by B. But again, here we're not interested in the true profit. We're interested in the difference between TVP and TVC, and that is the profit quote that the producer is interested. I should also mention that there's one particular case in the long run that you're in the long run, you remember that all of the fixed costs are equal to 0 because in the long run, all inputs are variable. And then in that case, TVC is equal to TFC. The black curve here, this profit curve here is going to be your long run profit. Before we start to find out what is the input level that will maximize profit, you might wonder, are there regions where the input use are not economical? So, and here, I mean, for the typical production function, if you still remember, there are 3 stages of production, and they actually are separated by the elasticity of production or factor of elasticity. So here is the elasticity where is equal to 1, and here is the elasticity where it is equal to 0. And this is stage 3, stage 2, and stage 1. So let's actually start with stage 3. So it is actually obvious that it's not optimal to use input more than X3 here. And why is that? Is because the TVP, if you notice, is actually decreasing if you use more of X3, and your TVC is increasing. So your costs of inputs are increasing, and your value of your output are decreasing. So imagine you're at point X3, and if you increase your input use by a little bit, then your profit is definitely gonna decrease. So imagine this as fertilizer use. So we don't even need to think about the cost of the input use. So even if the fertilizer is free, you're not gonna use that fertilizer. It's because if you use more fertilizer, your total value of product gonna decrease. So it's definitely not optimal to produce beyond X3. Well, it is obvious that stage 3 is not economical, and we don't even need to know the factor costs and the output price, and we can already decide that it's not optimal to produce in stage 3. And for the other 2 stages, we actually need to make some assumptions. So let's assume that the output price is fixed, is given, is not changing. And then at different factor prices, the producer's decision is actually going to be different. But however, as you will say that it's actually also not optimal to produce in stage 1. And the only region that is economical is stage 2. And where exactly at stage 2 to produce that the producer will get a maximized profit, it actually depends on the input and output price. But let me show you why it is not optimal to produce in stage 1. So let's first assume that the input price is equal to 9 here. I put R equal to 9. And you can see at this input price, the TVC curve actually is intersecting with TVP at point B. And what does that mean? It means that the difference between those two curves is 0. So TVC equals TVB profit equal to 0. And we can see from this profit curve that at X2, your profit is exactly 0. I also plotted the MVP curve and the MF curve or MF line. So again, MVP curve is actually the slope of TVP or the rate of change of TVP, and MFC is the rate of change of TVC, which is a variable cost. You can notice that at when the input is equal to X2, MVP is exactly the same as MFC, which is not by coincidence. So we showed a particular case where the input price is equal to 9. You don't really need to know what 9 means here, but it's just for your reference. So let's actually look at another case which is a little bit simple to see, is if your input price is higher than this 9 and what's going to happen. And as you can see here, as I increase the input price, then you can see TVC curve is actually above TVP curve. That means your variable cost is higher than the value of your product. So your profit is negative. And if you actually increase your variable cost more, you can see that the profit is going to be more negative. So under this case, where the input price is greater than 9, which is the input price where TVC is exactly the same as TVP. So once your once your input price is higher, then you always get negative profit, and it is always not economic to produce if the input price is higher than 9. So that's another case. So again, here you need to pay attention. The reason to not produce is because of the negative profit. And what about if the input price is lower than 9? Then we can also find that it's not economical to produce in first stage, which is to the left of X2, but we need to look at that region separately for the level of input less than X1, and also for the input that's between X1 and X2. I'll stop here today. Next lecture, we will find out why it is not economical to produce in stage 1, and at the exact what point the producer can reach maximum profit in stage 2.